Welcome to the Master of the NEC podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master of the NEC podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
What up, everybody? Welcome to another episode of Master the NEC, the podcast where we bring you all things electrical, code, business, and even electrical safety, which is kind of what we're going to talk about today, electrical safety. So thanks for taking the time out of your day to join us on the podcast or even subscribe to the various platforms that we distribute this podcast on. Again, it's been rated number one by many online podcast review sites. And again, we continue to put out information. Just a reminder that a lot of this stuff is very germane, regardless of the code cycle you're on. It's just good code or good electrical information. So I encourage you to check them out. There's over 1,000 episodes. You can get it from our mobile app, which is free. Just go to our website, fasttracksystem.com, and you can see under the navigation, under the info tab, you'll see a link to the mobile app. We're not putting anything on your phone. Don't worry about that. It's simply a web-based mobile app. That's the way we moved to a couple years ago, because I just don't like putting things in your phone. But it will put a quick link on your phone, or you can just go to the website, and you'll click the link on the website, and it'll open up in whatever device you have anyway. If you don't want to put anything on your phone, that's fine. But you can find everything over there, even our blogs. Now, some people say that blogging or the blogs are so no, it's still a little too far. So early 2000s or 2010s, and I disagree. I think blogs are an amazing way to get lessons to people. We can call them blogs all we want, but the reality is it's just a way to be able to have a short, very direct message, a lesson, if you will, and that's the best way to do them. And so we do that. And whether you're watching our videos or anything like that, if you want to get just a good lesson, there's nothing better than reading the information and be able to comprehend it. And that's the number one thing that I do notice with people when they struggle on electrical exams or struggling to learn the National Electrical Code. They have reading comprehension problems. And hey, I've been there. I'm just like you. Electrician started up from the field way back in the 80s. I've been an electrician, been a master electrician, owned multiple electrical contracting businesses, some more successful than others. Built a great company with my brother. Went on to build my own. I've worked for municipalities. I've been the engineer for the city of Richmond, supervisor of codes for the city of Alexandria, Virginia. I went on to work with NEMA as their electrical expert for the South, and then ended up with Encore Wire as their director of technical services. And now with Prismium, it's the world's largest wiring cable manufacturer. So I've been around the block a little bit and taught quite a few. I think it's over 80,000 students through the years. So, I'm telling you, you can get a lot out of the information that we share, whether you like me or not. It's not about me. It's about you and what you can learn. And we share you solid information on our blogs and things like that. So make sure you check it out. And you can do that from our website, again, or you can get the mobile app, whichever you choose. Today episode, first I want to tell you that we do have a new video that is out. It's 2 hours long. It's on establishing an electrically safe work condition, which everybody that works in the electrical industry, especially if you're working for somebody. I mean, if you're working for yourself, it's paramount because, you want to make sure that you go home every day. And when you work for somebody, it's it's extremely important that they provide you the tools to make sure that you also are safe. But you have to do your own due diligence. I mean, it's your responsibility to make sure that you stay safe on the job and you understand those type of things. So today we just want to talk a little bit, going to kind of paraphrase in an episode of what you would get in our 2-hour video over on Fast Track's Tube. Also, if you haven't subscribed, now we don't share as much stuff on YouTube anymore. That's, a lot of promotional stuff, a lot of salesy stuff, and people give us a lot of crap for that. But I'm being honest with you. I told y'all this 2 years ago. We're moving everything to Fast Track's Tube. It's a subscription platform. It helps support us. And if you just want free stuff, that's fine. You can linger over on YouTube, and that's fine. There's some great info over there. But we want to step it up a little bit. So over on Fast Track's Tube, all of our content is really stepped up. So and that's where we're going to be posting everything that we really do. Anything that's substantial. It's definitely going to be on Fast Track's Tube. And if you say, I don't want to subscribe, that's fine. You don't have to. You're not going to break my heart. But if you do want some good, it's basically less than a cup of coffee a day. So $99 a year. That's it. Unlimited. You can watch the videos, the webinars, the seminars that we have posted, these 2-hour videos, again, that type of thing. So anyway, all right. So thank you for joining me again. We're going to talk about establishing electrically safe work condition. We're going to be trying to do it as brief as possible because we do know we have a video out on that. So now, NFPA 70E is a document that's put out by NFPA, just like they put out NFPA 70, and they put out NFPA 72, NFPA 70B, which incidentally we will have training on for our thermography professionals as well. But everybody needs to understand about electrical safety, especially if you're going to be working in the industry. And I've told people this ad nausea, that you never, ever, 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 ever assume something is not live. You always assume that it's live. Always. Now, you're the one that makes the decision whether or not you want to move forward, whether it's simple or changing a luminaire in a dwelling and you don't want to test for absence of voltage. You're accountable for your own actions. Don't blame other people. You're accountable. So same thing happens here. Now, funny thing about companies, and when you're dealing with OSHA 1910 and all these type of things, one of the things that people fail to see is that there is a mutual understanding that has to take place between the employer, which may be you if you're a one-man show or have a couple people, or the employee. And so you're just not blindly going into the light, right? I try to tell people this all the time is electrician, you're always going to be responsible for your actions. Yeah, you're going to have bosses. Yeah, you're going to have people above you that tell you to do this or that, or whatever. But at the end of the day, nobody's responsible for your actions but you. Okay, if you get complacent or you don't follow procedure or you deviate from something for whatever reason, you listen to somebody's information that is inaccurate just because you assume that you trust them, that's on you. And I don't know how brutally honest that can be with many of you, especially people that have been hurt in the industry or whatever like that. I mean, at the end of the day, the responsibility is firmly in your hands. Now, the employer has a responsibility to make sure that if you're coming to work for them, that they provide adequate training, you have safety meetings, you're abreast of all changes in the environment, and that PPE is provided by the employer, lockout, tagout procedures, lockout, tagout equipment, all of these things, there's a mutual relationship that takes place. So when safety breaks down, it's rarely both sides. It's rare. It's usually one side breaks down and then, and it affects the other side or vice versa. Now, does both of them break down? Yes. It obviously, if a company doesn't do what they need to do and then you don't do your due diligence, then the whole system breaks down. But if the company doesn't provide what they need to provide and you keep your high standards of checking for absence of voltage, making sure you have proper PP available to you, if you balk at it because you don't have those things, then you're upholding this safety plan that needs to be in place. And so you, as an employee, need to always speak up because you may notice some deficiencies in the safety plan from the company, And it's your responsibility to speak up and not just say, well, I don't want to be that squeaky wheel. You have to be that squeaky wheel because there's other people involved that may not notice the deficiencies in an existing safety program. And maybe you just have this insight and it's your responsibility. Too many electricians aren't verbal enough when it comes to things like that. And of course, everybody, that gets hurt always plays, everybody plays Monday morning quarterback on that. But you hold that in your hand. I don't work on anything, obviously today I take a lot of shit from people, because I'm actively retired from in the field. I do help my brother out from time to time, but I'm actively retired now from in the field. This is what I do. I'm an expert in code. I teach code. And that old saying, those that teach can't do. They're so full of shit because we did it for so many years. How can we teach people if we didn't do it? But anyway, that makes them feel good about themselves. So they're going to say something like that. And that's fine. I don't have a problem with that. Whatever helps you feel better. But at the end of the day, you have to be accountable for your own actions, right? Just flat out. And so I tell people all the time, you have to stay constantly abreast of any changes that take place in the industry. If you're going to be involved in the industry, okay? Now, shift the gears to the electrical safety part of this. So today I'm going to talk a little bit about establishing electrically safe work condition. Again, I'm not going to take away from the 2-hour video that's over on Fast Track's Tube, which I encourage you to go check out. Fast Track's Tube, T-R-A-X, okay? Not T-R-A-C-K, it's T-R-A-X. Go check it out. You do have to be a subscriber, that type of thing. We probably will be doing a little sample sniglet video or something like that, snicklet or whatever you call it. We'll probably do that just so you can get a flavor for it. I don't think it's available now, but at the end of the day, check it out if you're a subscriber. If you're an enhanced Fast Track student, you should have access to it. Make sure you go check it out. I think you'll get a lot out of it because it is all about your safety. Now, NFPA 70E is a document that is updated every couple of years, just like the NEC is, right? Every 3 years. And it's designed to that if you follow it, then you will be compliant with OSHA. Now, OSHA is a hard document to change. There's legal aspects to that document. It is not consensus, and it is tough to change it. However, NFPA 70E, just like 70 and 70B, can be changed every 3 years. So the process of changing it helps look for weaknesses, deficiencies, and better safety compliance with any standard like an OSHA 1910. So that document is governed by NFPA, which is in charge of making sure that they go through the process, the consensus process of changes and updates and modifications in order to make sure it stays relevant. And it helps us with things that may come up that we weren't aware of in a safety deficiency manner. And it fixes it, right? So Article 120 covers the placement of electrical equipment in an electrically safe work condition, which means that the equipment is locked out, tagged out, tested for the absence of voltage, and where necessary, grounded. Now, OSHA and NFPA 70 follow the same line of reasoning with electrical lockout tagout procedures. So by virtue of understanding NFPA 70E, which is, be honest with you, it's going to be much easier to understand than the OSHA. Okay, so that's why most of your work sites, y'all talk about 70E and PPE and approach boundaries and all that, because NFPA 70E is a little easier to be able to palate. And of course, there's so many documents now with Link that actually have commentary, that if there's any questions you may have that you can ask, you can see it there and get a little additional clarity. So that makes it great for people, especially when it comes to safety, right? Having that information at your fingertips, it's great. While I may be upset at NFPA at their lack of allowing educators to use Link, I'm ignoring them and using the fair use, and I'm going to continue to use it whether they like it or not. If they want to cut me off, then cut me off. I'm continuing to use it. I am. And if they cut me off, I'll just get another account under some other weird name and some other account. I'll keep doing it until I keep doing it. I'm letting them know right now. Unless you can come up with a way to block an IP, and of course I can spoof an IP with the VPN. So I'm just already telling you, you might as well sue me, because as an educator, it is my responsibility to make sure that we convey accurate information. And sometimes when it comes to electrical safety, whether it's the 70 or 70E or 70B, paraphrasing is just not going to work. It's just not. Because you know what? And if you want to argue otherwise, then you're not really an educator. You're a wannabe. You don't get it. Okay? So, or if you want to suck the teat of NFPA, that's fine. I mean, I think they're a great organization, but again, they need to stop being so money-centric and realize that all of us out here produce those documents for them. All they do is compile those documents. Okay? That's it. They compile it, print it, distribute it. Shit, I can do that. I'm just saying. But it is a worthwhile association, and I encourage you to join. But again, I'm just hoping they get less about money. I'm just saying. Especially when you put yourself as a safety association. It's different if you're for profit. I get it. But if you're putting yourself out there as a safety organization, that's different. All right, anyway, so that's what we're going to be talking about today. The objectives of the video that is over on YouTube is to identify OSHA regulations and to give you an overview of a simple and a complex lockout tagout procedure, explain what is induced voltage versus backfed voltage, because they are different. It reminds me also, take an opportunity to go to our blog and read my blog on the differences in induced voltage, backfed voltage, and things like that, because it's a great article. And again, that's an example of where you can learn something. Again, people say that blogs are going out of style. I disagree. I read blogs all the freaking time. It's like mini technical manuals, if you will, if a blog is done right, if it's done right. We explain in the video that's over on Fast Tracks 2, we explain how to perform the absence of voltage testing and why it's so important as an electrician for you to do that before you touch anything. And I'll also remind you that these proximity testers, these tickers, we refer to them as tickers, can be a benefit in a lot of applications, but depending on the system, you never want to rely on them. And my brother says this all the time. He's like, yeah, I've got one, but I don't rely on it. And I'm like, without saying, you're right, I'll just say, oh, I agree. But he's absolutely right. You never rely on them. They might be good to give you an initial sense of what's there, but then you have to go to a meter. Now, whether you're using a high impedance or a low impedance, so you should have a meter that has both. There are ways around that to use things like a solenoid type meter or a meter that's like an old analog meter. There are ways that you can identify induced voltage versus backfed voltage and all that. But again, we have a great blog that actually walks you through how to do that. So if you're thinking, dude, I need to know how to do this, and I want to be a real electrician, then go read the blog, because I'll break it down for you. We also talk about in the video 3 types of instruments that can be used. Again, we talk about the solenoid type, we saw proximity, and we talk about a digital multimeter and all that kind of stuff. We do explain in the video lockout tagout principles that are covered in NFPA 70E 120.3, kind of go through each of those. Again, I explain the simple and complex lockout tagout procedure. Incidentally, the company you work for, if you work for a company that has multiple employees and you work in an environment where you're going to be working on equipment, switchgear, motors, industrial applications, and again, commercial as well. But again, if you're working with a group and you're working on larger projects, you need to make sure that there is a safety professional that's going to make sure that you have weekly meetings. And anytime there's a change in something, a new piece of equipment comes in, a new test equipment, new lockout tagout procedure changes, anything changes, they need to have a safety meeting and bring everybody up to speed. It's not cliche. It's what you should do. It's part of your electrical safety plan, and you need to do it. So whoever's listening out there, if you're the one that's in charge of the safety plan within your company, then that's on you. Okay, you make sure that you provide that for everybody, and you keep it updated. definitely. Any new people come on, they need to be brought up to speed. The other thing about that is all the electricians need to understand this and remember that they're brotherhood here. That when somebody new comes in and you know that they've never been seen at a safety meeting, whatever, that you stop and say, hey, we have safety protocols here. You might want to talk to the head guy or the head safety professional, whoever, the lead guy, whatever, to bring you up to speed. You might say, nah, I'm not going to talk to anybody. Well, that's a problem because we need communication. Not smart-ass communication, but communication. Share it with people. You're protecting each other in the trade. Electricity kills. It does. It's an amazing thing, but again, it can kill pretty quickly. Okay, so also in that we kind of briefly talk about the different equipment for lockout tagout and whether you can get away with a lock only, whether or not you can get away with a tag only. And those type of things. We kind of covered that in a video, so check that out. And of course, we also talk about when you're doing these tests and you simply just can't get rid of the voltage, whether it's induced voltage or whatever, then you need to ground out the system. So we kind of talk about the preventative type of a grounding system, temporary protective grounding system. We kind of touch on it, but again, that is something that it's as simple as clamping each of the lines to ground. When you're getting a certain level of voltage and you know that you've got things locked out, but you're still getting this low level and you can't get rid of it, then you can move on to the temporary protective grounding equipment. And it's very important when you do this. One, it can hinder your operation. Two, because of the ability for it to potentially get turned on and have that fault current, you need to be very aware of where you put this. So it's just not right in your face where you're working on the equipment. You have to look at the equipment. And so we kind of touch on that, but nothing's going to take the place of you doing this on site, right? Working with people on site in your professionals, that type of thing. So that's really important. Now, according to OSHA regulations, electrical equipment is not de-energized until it has been locked out, tagged out, or tested for the absence of voltage. And if needed, may need a grounding scheme that takes place in order to get rid of it. Again, remember, phantom voltage, even induced voltage, or even backfed, maybe from other sources. All this type of stuff needs to be rectified before you work on the equipment. Now, we do have such things as live work permits, and that is where turning power off could be a greater hazard than leaving it on. Very rare, requires work permits. Don't recommend it. There's very limited applications where you need to work on anything live, but that is something you need to talk with your company and make sure there's a bunch of crossing the T's, dotting the I's, proper PPE, fully aware of the situation, and be very justified in why you need to do it. Otherwise, there is no need to do it. Even OSHA 1910.333, I believe, says shut it down. Shut it down, de-energize it, make sure you check for the absence of it, check it before and check it after. It also reminds you to test your equipment, okay, which you should do. So we talk about lockout, tagout procedures in the video, and we also walk you through the process. And in that process, we're referring to things like 1910.147 and 1910.333. As well as NFPA 70E 120.5A4 for the requirements of a simple lockout tagout procedure. And then, of course, we kind of openly talk about the more complex of 120.5A5 when you're dealing with a more complex, like it's going to have a lockout tagout on a session that's going to go multiple days, or there's multiple crews that are working in the environment and things like that. That immediately takes it from a simple lockout tagout to a complex. We do cover that and get into detail in the video that's over on fasttrackstube.com for those that are interested. And we'll talk about sources of power in understanding that you nearly have to up-to-date electrical drawings, one-line drawings. You need to know where the possible sources are, where there may be transfer equipment, where there may be some type of switching that could put inadvertently re-energize something when you think you have it locked out. So again, it's on you. You don't take anybody's word for it. It's on you. Now, also it talks about drawings, and if you don't have one-line drawings, then you have to have something that is considered equally effective. Now, to be equally effective means that all sources must be clearly identifiable, and each employee involved, everybody that's involved in the system, must be able to access this information and understand how to perform lockout tagout. So again, as talking to an employer, you better have weekly meetings. You better make sure that everybody's clear on the process. And my advice, and I give this in the video, my advice is to document everything. Everything. I'm serious. Document it all. So, that way you're protected, right? So, and when we do, also, I talk about it. I don't really show you I'll show you some images of some meters, but a low voltage proximity tester and a low input impedance multimeter are used to determine induced or backfed voltages. Now, if a high input impedance multimeter does indicate voltage, a low input impedance multimeter is then used to measure the circuit, okay? Because a low input impedance voltage tester will effectively ground the circuit based on the meter's design if the voltage is induced, but it will not create an unsafe arc flash situation because you're using a meter that is actually class listed for the application you're using. Now, a low input impedance multimeter will either indicate voltage, which is a typical indication of backfed voltage, because remember, low impedance is going to ground it out. So if it's induced voltage, it'll get it to where you don't detect it. However, if you're using a low impedance and you are getting voltage, then that means it's probably not high probability that it is not induced voltage, but it is backfed voltage. Okay. So if that's the case, you've got to be very, very careful of that. Okay. So just be aware of that. And again, you can use low impedance multimeters, that type of thing as well. Let's see here. Now, if a low impedance voltage tester is measuring a voltage, even though it may be less than 100 volts, and a proximity tester, that's little ones like the little tickers, indicate the presence of voltage, then there's a high probability at that point that it's actually backfed voltage and it's not induced voltage. Okay. So anyway, we kind of look at that and show you some examples of a ticker. But again, nothing's going to take the place of using a multimeter. Preferably you have a multimeter that has a low impedance input and a high impedance input. Hopefully that's what you got. Testing for the absence of voltage, again, responsibility of the employee to do this, not the employer. The employee's responsibility to test this, okay, that type of thing. And we go through the lockout tagout procedures and kind of at nausea in that video. And so we talk a little bit about what's called the temporary protective grounding equipment as well. And I show a picture of that. So if you're thinking, what are you talking about? Basically, it's tying all the phases, checking for the absence of power. Now you're getting low levels of voltage. At this point, you're going to use protective devices that actually will allow you to clamp onto those and clamp it to the grounding scheme. And that will effectively reduce the voltage if that's what you're running into. But it's a process. And each one of those manufacturers of those temporary protective grounding equipment understand that. And of course, there's no one size fits all because, again, you could have fault current situations if something gets turned on or something happens. And so you need to make sure that that system is designed properly and that those conductors for that temporary protective grounding equipment scheme can actually handle the fault current. So there's a whole process here. We're not going to tell you how to size that. That is outside the scope. That is an engineered professional design system. And so we're not going to get into that. That's something that you need to not learn by listening to a podcast or watching a video online. You have to put your hands on it if you do it. Look at the manufacturer's recommendations. Talk to the design engineer, especially if they're asking you to work on something and you're not able to totally de-energize it because there is a presence of voltage. Well, then if there is any presence of voltage, you must do something to eliminate that. And that's where the temporary protective grounding system will come into play. Okay. Anyway, that's kind of an overview of what we're going to cover. over on that video. It's a 2-hour video. It's the one of a multi-part series. Over on, we'll probably have another one that gets more deep into lockout, tagout procedures as well. But this is kind of what it has to do with establishing an electrically safe work condition. So if you go in there with this mindset up front and realize that you're responsible for yourself. Yes, there's other things that the employer has to provide, but there's also things that you as the qualified person, and we're going to assume that you are the qualified person, right? So in that scenario, you have certain responsibilities as well. You share responsibility in the electrical safety program, okay? So, all right. Hopefully you got something out of that, folks. Appreciate you listening to today's episode. As always, subscribe and share it with other people. If you find it that you learned something, give us a thumbs up. We appreciate it. Until next time, folks, stay safe. God bless. We'll catch you on the next edition of Master the NEC.
Thanks for tuning into another electrifying episode of the Master the NEC podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master the NEC podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master the NEC podcast episode.